students. Today I will discuss about the point groups. In this lecture, I will tell you how we assign a point group to the molecules from the symmetry point of view. So first, what is a point group? A point group is a collection of all the symmetry elements and symmetry operations present in a molecule, and collectively I will assign a point group to a molecule. So molecules with the same symmetry elements are placed into a point group. So how we assign a point groups? There is a flow chart as I have shown here in this presentation. We first look at the molecule, then we observe whether the molecule is linear or not. If the molecule is linear, then, then we look for whether there is a center of inversion or not. If the center of inversion is not present, then we directly assign the molecule with a point group, means that molecule is having C infinity V point group. If the molecule is linear and there is no inversion center, then directly we assign the point group to the molecule as C infinity V. And if the molecule is possessing a inversion center, then there will be another rotation axis which is perpendicular to that principal axis. Then the molecule will have a point group D infinity H. Here we will take an example of suppose HCl molecule. Now if this is a HCl molecule, this is hydrogen and this is chlorine. Now we know that this molecule is a linear molecule and there is no inversion center. If there is no inversion center, then what is the possibility? The molecule is having a C infinity, means this is the rotation axis through which I will rotate the molecule through a very small degree of angles, and this molecule is seems to be a identical one. So this is its C infinity. And what else is present? Then the V is your mirror images, the vertical planes. How I cut the molecule? The cutting of the molecule will be infinitesimally small plane could be possible to this molecule. So this molecule, which is linear in nature and does not have any inversion center, then the point group is directly assigned to the molecule as C infinity V. And if the molecule is having a inversion center, means inversion center means if appended atoms are passed in a attached through each other and they are passing through a common point, then the molecule is have to possess a inversion center. Suppose this is the example of carbon dioxide, where this is the carbon and these two are the oxygen atom. The carbon is possessing a center of inversion, and this molecule is having one principal axis which is C infinity, and there is another principal axis, another rotation axis which is your C2, through which I rotate the molecule to get the identical structure. Now there is C infinity, this is C2, C2 is perpendicular to C infinity. Now the point group is changed from C infinity to D infinity. So that's why for the linear molecule which possess a center of inversion, they are assigned with the point group D infinity H. Now, if the molecule is not linear, then we look for whether there are more than two CN axes or not. If the molecule is possessing more than two CN axes, then again we look for whether the center of inversion is there or not. If the molecule is possessing more than two CN axes and the molecule is possessing an inversion center, then we will look for whether the molecule is having C5 or not. If the molecule is having C5, then the point group is directly assigned as the IH, means icosahedral. Structure is icosahedral and directly point group is assigned as IH. And if the C5 is not present in that molecule, C5 is not there, Means the molecule was having C6 and having C4, the molecule is having C2, like that, more than 2 C2 axis, CN axis, then the point group is directly given as OH, means the structure is octahedral. And if the molecule is not possessing any center of inversion, but still the molecule is possessing more than 2 CN axes, then but with no inversion center, that means the structure is your tetrahedral structure. And tetrahedral structure, for the tetrahedral structures with the same symmetry, all the atoms are same, then the point group is directly assigned as TD, tetrahedral, for the tetrahedral molecules. So all these groups, the IH, OH, TD, all these point groups are called as the cubic group because they are higher order axis groups. Whereas for the linear molecules, where we assign the point group C infinity V or D infinity H, these type of point groups are called as the linear groups. Now I will talk about if the molecule is possessing CN axis, but that CN is not greater than 2, then how we assign the point group. Now if the molecule is having CN, okay, and if the CN is there, first I will talk about if there are not more than 2 CN. Okay, means the molecule is possessing one rotation axis, but not more than 2 or not more than, its 2 or not more than 2. Then we look for what type of mirror planes are present in the molecule. Now we are looking at the sigma, means the mirror images, mirror planes. If the molecule is possessing a mirror plane, then but there is no CN present in the molecule. There is nothing, no rotation axis in the molecule. But that molecule is possessing only the mirror plane. That example is like the planar molecule. It's a planar molecule. Let us take example of a planar molecule where suppose this is one atom and all the 3 atoms are attached to this molecule are different. Suppose this is platinum, sorry, phosphorus, chloro, bromo, and iodine. Now all the atoms are different, so there could not be possible any rotation axis. The only possibility is the mirror plane. If only mirror plane is present in the molecule, then point group is the CS. CS means there is no rotation axis, but only possibility is there is one mirror plane. If molecule is possessing any, is not possessing any rotation axis but possessing only the mirror plane, then point group is CS. And if there is no mirror plane but only the molecule is possessing the center of inversion, then the point group is CI. CI means I stands for your inversion center. And if the molecule is not possessing any inversion sector, no rotation axis, no mirror plane, then the point group is assigned as C1. C1 means there is nothing present in the molecule. The molecule is possessing only the identity, nothing else. Now, if the, again I am coming to the CN axis, the molecule is possessing only the rotation axis. Now, if the rotation axis is possible, then we select whether there is any other highest n axis is possible in that molecule or not, or if there is a possibility of perpendicular C2 axis to the CN. CN means your principal axis. Along with that principal axis, if there is a possibility of any another C2 axis which is perpendicular to the CN axis, if there is C2 perpendicular to CN, then we look for whether the molecule is possessing any horizontal plane or not. If the molecule is possessing a horizontal plane along with the C2 perpendicular to CN axis, then the point group is assigned as DNH. Please remember that If the molecule is possessing only the one principal axis, only one rotation axis, then point group is assigned as Cn. And if there is another C2 axis perpendicular to that Cn axis, then point group is changed from Cn to Dn. As I have done over here, Cn, C2 is perpendicular, and if horizontal plane is there, then DNH. If it is not a horizontal plane, but a dihedral plane, then the point group will be D and D. And if there is no horizontal plane, no dihedral plane, then point group will be DN. And if there is no C2 perpendicular to the Cn axis, then the point group will be your Cn category. That could be CNB, CNH. Then we will look for whether the vertical planes are there or not. If the vertical planes are there, then the point group will be assigned as CNV. And if the horizontal plane is there, then point group is assigned as CNH. And along with CNV, if there is another S2N axis, then it will be assigned as SNH or SNV. And if there is no CN, the SN, then the point group is directly assigned as CN. I'm repeating it again. We will look for whether there are some planes or not. The plane could be your horizontal plane or the vertical plane. If both the vertical plane and horizontal planes are present in the molecule, then the preference will go to your horizontal planes. And if the vertical planes are there and along with that there is improper rotation axis, then that point group is assigned as to be the SN. And if there is no improper rotation axis, then point group is assigned with the Cn point groups. So this was all about the flow chart, how we assign the molecule, how we visualize at the molecules. Then in the next lecture, we will take some examples of the molecules and then we assign the point groups out to the molecules. Thank you very much.